All right, guys, today we're talking about factoring. So we did the basics earlier in the year whenever we were factoring quadratics. Same principles apply to any polynomial. First step is always going to be GCF, greatest common factor. Find what that is, take it out first. Looking at this number 1, 12a cubed plus 10a squared. They both have 2 in them, and they both have 2 a's in them, a squared. Whenever we're factoring, we're undistributing, we're dividing these terms. So 12 divided by 2 is 6. A cubed divided by a squared is a. 10 divided by 2 is 5. Don't forget the plus. A squared divided by a squared is 1. Anything divided by itself is 1. And 5 times 1 is just 5. So I'm going to leave it like that. That's factor. There's nothing else we can do with this one. That's the GCF. Done. Next, 14 and 7. They both have a 7 in common. How many m's do we have? Well, this one has 8 and that one has 2, so that's a total of 2 in common. This one has 5 n's, this one has 2 n's. They've got 2 n's in common. 14 divided by 7, that's 2. M to the 8th divided by m squared, m to the 6th. Remember, we're subtracting when we divide. We subtract the exponents when we divide, same base. N to the 5th divided by n squared is n cubed. And then if we notice, this is the same thing, right? 7 divided by 7 is 1. M squared divided by m squared is 1. N squared divided by n squared is 1. 1 times 1 times 1 is just 1. Make sure you put the 1 though, minus 1. I already say it cancels and leave it out of there. It cancels to a 1, not a 0. And that is your factor right here. It's factored. That's factored form. Took out your GCF. Looking at this, there's nothing else we can do. We're done. Okay. Now, we also did difference of squares already when we're dealing with quadratics. So if we look, this is the rule. A squared minus b squared, that's the difference of squares, is equal to a minus b times a plus b. So the main thing is figuring out what's a and what's b. Now to help you out, I listed out some of your perfect squares up here, 1 through 12's squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 6 squared is 36, 9 squared is 81, etc., etc. So you need to be able to recognize those. So whenever you're looking at this, obviously it needs to have a minus because it's a difference of squares. So it is minus 9 and 49, well that's 3 and that's 7 squared. So if I look, what is a here? I'm just going to write it out this one time. A is 3 for the 9, and whenever we're looking at our variables, we're taking basically the square root of x squared. And if you remember, square root's the 1/2 power. So what's half of 2? 1. So that's x to the first power. Try it out. What's 3x times 3x? 3 times 3 is 9. X times x is x squared. It works. B, on the other hand, well, that's a 49 has a square root of 7. The square root of y squared is y. All you have to do is divide your exponents by 2, because that's how you take the square root, the 1/2 power, whenever you have the same base. So then we can just write out our factors. A minus b times a plus b. And now that's factored. I'm looking again inside. There's nothing else we can do. Sometimes there will be. But as far as this one's concerned, it's done. So let's look at the next one. Okay, I'm looking here, 72 and 2. Oh no, they're not up there. So those aren't perfect squares. I'm done, right? Wrong. What's step number 1? Always. factor out your GCF. In this case, it's a 2. 36 c to the 4th minus 1. Factor out 2 from this one, 36c to the 4th. 2 from this one, 1. Now I look, yeah, 36, well, that's 6 squared. It's a perfect square. This thing's even, so that'll work. C to the 4th, I can divide that by 2. So if I think about it, the square root of 36 is 6. And the square root of c to the 4th is c squared. So that's my a term. 1, well, that's easy enough. The square root of 1 is 1. So that's a minus b. Don't forget to keep this 2 on there. Your GCF needs to stay out front. And we also have a plus b. So it's just these exact two things right here, but with a plus sign between them. Okay. Next on the list, we have number 5. Check out its GCF. 7 and 28 both have a 7 in common. Now let's say you don't know your multiples or your factors or anything like that. But if you have the calculator I told you to get, it does. Wait for a second. So you can go alpha multiplication and type in your 2 factors. You can only do 2 at a time though, and only numbers. So you do the 7, sorry, I don't know why I put 2 there. And we need to put a comma right here. Shift, close parenthesis, 28. And that is a greatest common factor of 7. GCD stands for greatest common divisor. And that's how we think about our GCFs. They are GCDs of our monomials. Now, 7 for the numbers. I have 7 m's here, 1 m there, so I got 1 m in common. 1 n there, 3 n's over there, 1 n in common. Factor it out. 7, well, that's just 1. I'm not going to bother writing a 1. Into the 7th, 7 minus 1 is 6, so n to the 6th. N is factored out. Okay, done. 28 divided by 7, well, that's 4. N divided by m is 1 again, so it's factored out. Done. N cubed, so 3 minus 1 is 2, so n squared. Okay. So I have 7m in a. Well, this is a squared, so I take half of the power, 3. So it's going to be m cubed minus, see, here's my formula right here I'm following. The square root of 4 is 2. Square root of n squared, 2 divided by 2 is 1, so it's 2m times m cubed plus 2n. And that is my factor right there. Sometimes you'll be able to break it down further. This might also be a perfect square, or sorry, a difference of squares. So you'd have to do it again. In this case, it is not, but always check after you think you're done, make sure you're done. Check and make sure there's nothing else you can factor out of these things. All right, over here, GCF of 10w. I'm left with w to the 4th minus 1. Okay, so that's 10w. The square root of 4, the square root of w to the 4th is w squared minus 1. Square root of 1 is 1. And w squared plus 1. And as it so happens, that is exactly what I was just talking about. This is also a difference of squares, isn't it? It's w squared minus 1, so we can do it again. 10w, that's not going anywhere. The square root of w squared is w minus square root of 1 is 1 times w plus 1. This one, though, that's a plus. You see that? That's a minus. So you can't do anything with that one. So leave it as is. So always, always go back and check. Make sure there's nothing else you can do with these. If it's the difference of squares or somehow there's a GCF you missed, go back and check. Okay. Now there's nothing else we can do. Let's talk about something new, because both of those were things we've already discussed. Sum of cubes. Okay. So I listed out your perfect cubes. 1 to the third is 1, 2 to the third is 8, 3 to the third is 27, all the way up to 10 to the third is 1,000. Be familiar with those. A cubed plus B cubed, that factors as A plus B times A squared minus AB plus B squared. So again, first thing you want to do is figure out what A and B are. So A would be the cube root of x cubed, which is just x, plus, because it's a plus, and that formula has a plus right there. The cube root of 27, so 3 times 3 times 3, yeah, that's 27. X plus 3. That's A, that's B. Now, I need to do the second part of the formula. X squared minus 3x plus 9. Okay, where'd I get the 9 from? 3 squared. Okay, and you can check it. And obviously, nothing else we can do there. Here, we'd have to think about this trinomial. Does it factor? It does not. I can see that it does not. We're going to get there in a few minutes whenever we do that. But I can assure you that this does not factor, so we're going to the next one. GCF is nothing, so let's keep doing it. M, that's obviously that one. Ooh, 216. That's right here. 1, 2, 3, 4, 5, 6. Oh, that's 6. Okay. N cubed would be N. So A is M. B is 6N. Plug it in this formula. A squared, M squared, minus AB, 6N times M, 6NM. Or MN, doesn't matter. Really doesn't at all. Multiplication is commutative. Plus, now 6n squared, so that's 36n squared. 6n times 6n. Next on the list, got this guy going on. Aha. GCF, 4. Take it out of there. Because I was looking up here, 500 is not up there. What if I divide 500 by 4? I get 125. A cubed plus 1. Okay, that's the GCF. Am I done? Let's check. Oh, that's a cube, that's a cube, and that's a cube. Not done. It's a difference of cube, or sorry, this is the sum of cubes. Yeah, it's a plus sign right there. Pay attention. So we can factor that again. The cube root of 125 is 5. Cube root of A cubed is A plus 1. That's A, that's B. Plug it in there. 5A squared is 25A squared minus 5A times 1 is 5A plus 1 squared is 1. Checking it again, 25, nope, nothing that's gonna happen there. Okay, wait, no, doesn't work. So next one, GCF. Well, if you don't know 3, you can always take your calculator. Alpha multiply 24, comma 375, and sure enough, that's 3. That's 4 C's there and 1 there, so that's C, 1 C, D, and D 4, so that's 1 D. Factor it out. Again, every time your first step is GCF. Second. So GCF, that leaves me with 8C cubed plus 125 D cubed. Write down your GCF, just stick it out front. Cube root of 8 is 2, cube root of C cubed is C, so that's A. Cube root of 125 is 5, cube root of D cubed is D, that's B. Plug it in. 2C squared is 4C squared. Obviously I can't say parentheses in the air, but whatever. 2C squared is what's going on here if you're confused. Minus 2C times 5D is 10DC or CD, your choice. I'm going to go with CD. And 25D squared. Now let me think about this. Nope, that's not gonna work there. Okay. Done. Move on to the next one. So that's the sum of cubes. I did not. The difference of cubes is almost the exact same formula. We just changed 3 signs. This one, this one, and this one. And that is your new formula. So it's the exact same process. Just find out what A is, put it in the formula. But a lot of times, whenever you have a difference of cubes, that first term might break down into a difference of squares. Won't happen here, but it can. So you got to pay attention to that. So let's just do it. Is this the same as the previous one? No, okay, close enough. So obviously A is X, and obviously B is 1. So minus 1. It's always going to be starting with this sign here. Whether it's a sum or difference, it's going to be right there. And then the only difference is this next sign. It's the opposite. So you are expected to memorize this formula and the previous one, and any others. A squared, X squared, plus 1 times X is X, plus 1. 1 squared is 1. Check, no GCF here. 216, that's 6. So 6K is my A, minus 5. Square that, plus the product, 5 and 6 makes 30, plus 25. Checking, I'm pretty sure these won't work. Well, I can't check that in my head, but I can almost guarantee it's not going to work. So I'm not worried about that because we actually haven't done these yet. We have, but we haven't done them yet this lesson. So that should be fine. I'll check it later if we need to. Oh no, 4 is not a perfect, oh, GCF. So 4, 1 minus 8, H cubed. So that's 4, 1 minus the cube root of that is 2h. This squared, that was hard, plus this times this, plus this squared. That's it. And again, not going to work. GCF here is 2. X cubed minus 27y cubed. That's going to be 2x minus 3y. The more you do this, the more fluent you'll be able to, oh yeah, that's 27, that's 3 cubed. Be able to recognize your A and your B takes a lot, just takes a lot of practice, that's all. X squared minus 3xy plus 9y squared. Okay, that's a difference of cubes. Now, we've talked about factoring trinomials before. We showed you that box thing. I don't like the box, that's terrible. Guessing and checking, that's also pretty terrible. AC method. Now, I showed you how to get the answer and then work backwards, but you can actually just use the AC method and be done. Now, whenever you're looking right here, that's into the 4th power. We're only dealing with quadratics, right? Guess what? This is a quadratic. This is n squared squared, and that's n squared is, yeah. So it works, it's a quadratic. So we can factor it just like we do a quadratic. So we know it's going to look something like this. This is into the 4th. It's what squared? It's n squared squared, right? So that's what's going to be right here and right here. Now, I'm going to show you could probably do it just by looking at this one now, but I'm going to show you the AC modified shortcut, blah, 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 whatever word you want to call it thing. All right, so A times C, that's 1 times negative 24 is negative 24. We need the factors of that add up to B, 2. Go through your factors, do your math facts, divide on the calculator if you have to. I don't care. It needs to be a positive 2, so the bigger number has to be positive. So negative 1 and 24 obviously doesn't work. Negative 2 and 12, oh hey, that works. 10, oh wait, no, it doesn't work. Negative 3 and 8, that doesn't work. Negative 4 and 6, oh fine, there we go. So how did I get these? I know my math facts. How do you get them if you don't know math facts? 24 divided by 2 is 12. So 2 and 12. 3, 3 and 8. 5 doesn't work, etc. Till you find what you need. But if you know your math facts, it saves yourself a lot of time. Now, you take these and you put them over A and simplify. So negative 4 over 1 and 6 over 1. Simplify that. That's negative 4 over 1, keep it over 1, and 6 over 1. Here's what you do. This number on the bottom, that's the number that's going right here. This number on top, that's the number that's going right here. Obviously, you don't have to write the ones. So that needs to be 1, and that's a positive 6. Check it out. Get rid of that 1 right there. It's annoying me. Sorry. Goodbye. Okay, there. Beautiful. So we can check, distributed. N squared times n squared is n to the 4th. N squared times 6, that's 6n squared. Negative 4 times n squared minus 4n squared is indeed that 2n squared. And negative 4 times 6 is negative 24. So that's how you can use the AC shortcut to factor even easier. But what's the first step always? No, I didn't freeze. I was just staring at you. GCF, W. W squared plus w minus 20. Okay, here we go. It's something and it's something. That's got to be some sort of w, because the square root of w squared is w and a w. I might have something on the bottom here. If this is 1, you won't have anything on the bottom, so this will just stay 1. Okay. Negative 20, that adds up to 1. Well, it's a positive 1, that's going to be a negative 4 and a 5. Go through it if you got to. I don't have time for that. So that's negative 4 over 1 and 5 over 1. We're always putting them over a. This is our a right here. That's going to be negative 4. That's going to be 5. Don't forget your plus sign. We factored that thing. Okay. So that's the AC method, as short as it possibly can be. Let's try a couple more and see if I have more coffee. Dude, excellent. Let's see. GCF. A and a 2. They all got a 2 in them, they all got an a in them. So let's write down what we're left with. A squared plus 19a plus 34. So I know that's going to factor something like this. We're looking at a after we factor out the GCF, after the GCF. So this right here is 1. So that's our a is 1, okay? Not this one, after the GCF. Not this, not this. The 1 here. So yeah, that's going to be obviously a squared and a squared because that's just a 1. A and a. Sorry, I misspoke. It's the square root of a squared, which is a. But you can always just leave some space and then go back and fill it in if you need to. 1 times 34 is 34. It's positive this time. Looking for 19. I'm just going to go with 2 and 17. Hey, that works. So 2 over 1, simplify, done. 17 over 1, simplify, and done. Okay, so 2, 17, plus, and a plus. Factored. Move on. GCF is x. Let me go back for a second. Aha. They got me. They got me. They did. I was all excited about this. I missed it. So let's go back and look at number 15. It's not done yet. Look at that. What is that? That's a difference of squares, isn't it? So I can factor that further. N minus 2, n plus 2, and n squared plus 6. They got me. Sorry, guys. These are good because those are just the first power. But yeah, if you have, a difference of squares, you still need to finish factoring it. So that was my bad. Got too excited about the AC modified shortcut thing. I was looking at this and I was like, oh wait, I wonder if that's gonna, ooh, and yeah. Didn't finish a single statement there, did I? Whatever. So I factor out an x and we're left with x to the 4th. And that reminded me of, oh hey, I might have a difference of squares. And then, oh hey, I might have had a difference of squares back there, which we did. So yeah. Now, okay, GCF's factored out. Let's factor this thing. What's the square root of x to the 4th? X squared. There's a 1 in there, so I'm not going to have to worry about anything in front of that. So it's going to be x squared something and x squared something. If it factors, it might not. This might not factor, we don't know. But the AC method will tell you if it does or does not. It's a negative, oh, obviously, negative 25 to make a negative 24. Hopefully you can figure that one out. 1 and negative 25. Put them over A, they're both, yeah. So that's plus 1 minus 25. So I'm going to do minus 25 and plus 1. Why did I do that first? Because I just felt like it. But look at that. See, we got a difference of squares again, don't we? Always check. Take your own advice. Always check. Make sure you're done before you're done. There we go. X squared minus 25. That's x minus 5 times x plus 5. This is a positive right there, so ain't no thing can do with it. All right. Yep, that's about right. And okay, now let's do those. And I'll have to say this one for next time because it's almost time for class. So again, GCF, nada. So let's factor this thing. No GCF, so I'm gonna have something like this. This time A is not 1. A is not 1. So I'm gonna do still x to the 4th, you're square rooting that is gonna be x squared, right? But leave some space because you might have to stick something in front of it. I'm kind of a big writer. Anyway, let's do the AC shortcut. 3 times negative 5, that's negative 15. So this is where it comes in much handier. It needs to be 14. Okay, so that's obviously a positive 15 and a negative 1. Put them over A. Negative 1 over 3. 15 over 3. Simplify. Oh, that one doesn't. This one does. That's going to be 5 over 1. Keep it as a fraction. Because remember, that's what's going to go in front of your x squared or your x or whatever's up in here. And that's what's going to go right here. 3 minus 1. 1 plus 5. Okay, let's check it out. Make sure it worked. 3x squared times 5. 15x squared. Okay. Negative 1 times x squared minus x squared. 15 minus 1 is indeed 14x squared. We're good. And they didn't trick me on this one. That's not a difference of squares because that 3 is not a perfect square now, is it? If that would have been like a 4 or 1 or something, then yeah, it would have worked, but it doesn't. Move on to the next one. GCF doesn't exist. So I'm gonna do something like this. I know I got some sort of m squareds in here. I might have them with coefficients. I might not. I'm just gonna leave some space to stick something in front of them if I need it. 9 times 4 is 36. Need that to add up to negative 12. Positive and negative, that means they both have to be negative. So my factors of 36. 6 and 6, hey, that works. So negative 6 and negative 6 gives me negative 12 if I combine them and positive 36 if I multiply them. Put them over negative 6 over 9 and negative 6 over 9. Okay, same thing. Simplify. Negative 2 over 3 on both of them, obviously. That means that's going to be 3 m squared minus 2. 3 m squared minus 2. Not a difference of squares because that and that are not perfect squares. Now we could rewrite this as 3 m squared minus 2 squared, because it's the same thing times itself, right? And we will be doing that later for multiplicity's sake, but right now I'll take either one. We still need to talk about 4 terms, but we'll do that another video because, yeah, class time. So 4 terms, we're just going to use grouping. And if it doesn't work, then, well, we won't worry about it. We'll talk later about the ones that don't work. For now, though, AC shortcut, make sure you learn it. Make sure you learn your formulas for difference of cubes, sum of cubes, and difference of squares. Right there, there, and there. And make sure you know your perfect cubes and your perfect squares, or at least have an idea of them. And of course, you could always test. You could do, is 121 a perfect square? Let me see. I'll do the square root of that. And, square root of 121 is 11. It's a perfect square. A cube root. So to do a cube root, you got 2 options. You can do shift, square root, and how about 81? Is that one? It's not. Oh, man. 343. Oh, that's 7. Okay. So you can test and see if that's a perfect cube or not. All right. The end. I'll see you next time. Goodbye.